Okay, good morning. Now today we will see the theory part of the gear. Earlier we have seen basic part, that is types of gear, what is the importance of design, why design of components or machine elements is required. Therefore, another theoretical part is there that we will see. This theoretical part it has been already covered in second year theory of machines, that is kinematics and theory of machines subject, but still it is necessary that you must know all the terminology of the gears. Therefore, terms used in gears or terminology used in gears. Now you just say, this is the gear, this is the spur gear. Now, whenever a gear is in your hand, if you will take this gear in your hand, and if I will tell you to identify pitch circle, base circle, whether it is possible for you to identify it, it is not possible, because this pitch circle is nothing but center line of this gear tooth or center line of this gear teeth. Therefore, this pitch circle is nothing but what? It is imaginary circle. Just like I have told yesterday, the definition of axis. Axis means what? It is an imaginary line. It is an imaginary line which converts whatever thing is there, whatever parts are there, into equal parts, equal symmetric parts about that axis. Therefore, that is the definition of axis. Now, you are observing here that different terms are there: circular pitch, addendum circle, pitch circle, base circle, dedendum circle. Now, first definition is pitch circle. Therefore, if gear will be in your hand, you can't identify where is the pitch circle. Therefore, what is the definition? Pitch circle, it is an imaginary circle which by pure rolling action would give the same motion as that of the actual gear. Now, always remember, gear is usually specified in terms of pitch circle diameter. If I will say that gear is of 200 mm diameter, gear is of 200 mm diameter, therefore 200 mm is nothing but its pitch circle diameter. 200 mm is nothing but its pitch circle diameter. Next is the pitch circle diameter. It is the diameter of the pitch circle. The size of the gear is usually specified by the pitch circle diameter. It is also known as pitch diameter. Therefore, whatever this whole circle is there, that diameter of this circle or pitch circle is known as pitch circle diameter. Now, next is the pitch point. Pitch point means nothing but what? It is a common point of contact between two pitch circles. That is, you are knowing that when gears are there, two gears are in contact with each other. Just I will say, here it will not be there. When two gears are in contact with each other, at that time their common point of contact is known as pitch point. Next is the pitch surface. Now you just see here, this is the pitch surface. Pitch surface element. In this figure it is more clear. This is the pitch surface. Therefore, pitch surface, it is the surface of the rolling discs which the meshing gears have replaced at the pitch circle. It is the surface of the rolling disc which the meshing gears have replaced at the pitch circle. Next, that is important definition, pressure angle or angle of obliquity. It is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. It is usually denoted by letter phi. The standard pressure angles are 14.5 degree and 20 degree. Means only two pressure angles are there in gear, that is 14.5 degree and 20 degrees. Now from this figure, the definitions are more clear to you. See that this middle circle is there, that is pitch circle. This is the pitch surface element. This is the face, this is the flank. Now this is the tooth thickness. It is measured along the pitch circle. This is the tooth space. Tooth space, that is space between the two teeth measured along the pitch circle. This is the circular pitch. That is, it is the distance measured on the circumference of the pitch circle from point of one tooth to the corresponding point on the next tooth. Therefore, this whole length of this arc is known as circular pitch. See that this is the addendum, this is dedendum, this is face width, this circle passing from the top of the teeth, addendum circle, this is top land, this is bottom land, working depth, this is total depth. Difference between total depth and working depth is known as clearance. Therefore, all these definitions we will see now. The circle passing from the bottom of the teeth is known as root circle or dedendum circle. Now just see here, addendum. It is the radial distance of a tooth from the pitch circle to the top of the tooth. See that this is the addendum. Now, gear, it is of maximum shape of the gear used in practice is of circular shape. Always remember. Therefore, whenever circle will be there, therefore it may be having some center. It may be having some center. Therefore, the line which passes through the center of the circle is known as radial line. There, that's why this addendum is nothing but it is the radial distance of a tooth from the pitch circle to the top of the tooth. See that this is the addendum. If you will extend this line like this, it will pass through the center of the gear. Similarly, dedendum. It is the radial distance of a tooth from the pitch circle to the bottom of the tooth. Pitch circle to the bottom of the tooth, radial distance. Next is addendum circle. It is a circle drawn through the top of the teeth and is concentric with the pitch circle. The circle drawn through the top of the teeth and is concentric with the pitch circle. Similarly, dedendum circle. It is the circle drawn through the bottom of the teeth. It is also called root circle. The circle passing from the bottom of the teeth and is concentric with the pitch circle is known as root circle. Dedendum circle. Again, same definitions are there. Let it be. Now, next is circular pitch. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. See that if you will take this point and you will go from along the pitch circle, therefore you have to take similar point on the next tooth. Therefore, this distance is known as circular pitch. It is the distance measured along the circumference of the pitch circle. Now, mathematically, circular pitch is denoted by PC. Therefore, PC is equal to D by T, where D is nothing but diameter of the pitch circle and T is nothing but number of teeth on the wheel. A little consideration will show that when two gears will mesh together correctly, if the circular pitch between the two gears must remain same. That is, for the two gears, when two gears are in contact with each other, always remember their circular pitch is same. If circular pitch will not be same, the two gears will not be in contact with each other. Remember always. Next is the diametral pitch. It is the ratio of number of teeth to the pitch circle diameter in millimeters. Therefore, it is denoted by PD. Mathematically, diametral pitch PD is equal to T divided by D, where T is equal to number of teeth and D is equal to pitch circle diameter. Now, next definition is module. It is the ratio of the pitch circle diameter in millimeters to the number of teeth. Therefore, it is usually denoted by M. Therefore, mathematically, module M is equal to D divided by T. Now, next is clearance. It is the radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. A circle passing through the top of the meshing gear is known as clearance circle. Therefore, if like this, if two gears are in contact with each other like this, suppose these fingers, upper finger, whatever these upper fingers are there, this top of the teeth and lower fingers, bottom of the teeth. Therefore, this space you are observing, that is known as clearance. Next is total depth. It is the radial distance between the addendum and the dedendum circles of a gear. Means addition of addendum plus dedendum or addition of addendum and dedendum is known as total depth. Therefore, this is the addendum and this is the dedendum. Therefore, addition of these two is nothing but total depth. It is equal to the sum of the addendum and dedendum. Next is working depth. It is the radial distance from the addendum circle to the clearance circle. It is the radial distance from the addendum. See that this is the addendum circle and this is the clearance circle. Therefore, this is nothing but radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Next is tooth thickness. It is the width of the tooth measured along the pitch circle. See that this is the tooth thickness. This is pitch circle. Therefore, it is the width of the tooth. It is the width of the tooth measured along the pitch circle. Then tooth space. See that this is tooth space. It is the width of the tooth measured along the pitch circle. It is the width of space between two adjacent teeth measured along the pitch circle. Therefore, space means in Marathi it is called as रिकामी जागा किंवा पोकळ जागा. Space रिकामी जागा म्हणजे this. It is the width of space between the two adjacent teeth measured along the pitch circle. Then next is the backlash. It is the difference between the tooth space and tooth thickness as measured along the pitch circle. Theoretically, the backlash should be 0, but in actual practice, some backlash must be allowed to prevent jamming of the teeth due to the tooth errors and thermal expansion. Therefore, when two gears are in contact with each other, teeth of the two gear, at that time there must be a backlash in terms of microns. Why in terms of microns? Because this backlash must be provided or allowed to prevent jamming of the teeth due to tooth errors and thermal expansion. Next is face of the tooth. It is the surface of the gear tooth above the pitch surface. Flank of the tooth. It is the surface of the gear tooth below the pitch surface. See that this is the pitch surface. The surface which is above the pitch surface is known as face. The surface which is below the pitch surface is known as flank. Then next is topland. It is the surface of the top of the tooth. See that this is topland. It is the surface of the top of the tooth. Bottomland. It is the surface at the bottom of the tooth. Whatever this at the bottom, this surface is there. This is known as bottomland. Next is face width. It is the width of the gear tooth measured parallel to its axis. See that. Face width. Width of the gear tooth measured parallel to its axis. Next is fillet radius. It is the radius that connects the root circle to the profile of the tooth. See that this is the root circle or dedendum circle. And this is the profile. What is the profile? It is a curve formed by face and flank of the tooth. Whatever this curve is there, this is the curve formed by the face and flank of the tooth. That's why it is known as profile. Therefore, this small radius is there. That small radius which connects this profile of the tooth to the dedendum circle is known as fillet radius. Now next is very much important, that is standard systems of gear tooth. Standard systems of gear tooth. Therefore, standard systems of gear tooth are classified according to the pressure angles. Therefore, you are knowing that there are only two pressure angles, 14.5 degree and 20 degree. Therefore, first of all, we will see 14.5 degree full depth involved system. See that. First of all, I will explain this figure. In case of this 14.5 degree full depth involved system, see that this lower, this is suppose center line of this rack cutter. Center line means you can take this as pitch circle line. In gear, it is known as pitch circle line or pitch line. Now the portion below the pitch line is known as dedendum. The portion above the pitch line is known as addendum. Now, if you will see, these proportions are there. In case of 14.5 degree full depth involved system, addendum is 1 times module. 1 times module. Suppose my module you will take 5 mm. Therefore, 1 into 5 means 5 mm. Addendum height will be there. Similarly, dedendum, which is nothing but portion below the pitch line. Therefore, its proportion is 1.157 times module. Therefore, 1.157 into 5 mm, that will be your dedendum. Now, this is tooth space, 1.5708 times module. Therefore, 1.5708 into 5, that much will be tooth space. This is tooth thickness. Its proportion is 1.5708 times module. And how to identify this 14.5 degree? Because these teeth are there. They are making an angle of 14.5 degree with respect to the vertical. With respect to the vertical, that's why it is known as 14.5 degree full depth involved system. Now, if we will say this is the gear tooth manufactured by 14.5 degree this rack cutter. Therefore, this 14.5 degree full depth gear tooth is there. If you will see, or if you will extend these arcs like this arc will pass through the center of the gear, or this profile will pass through the center of the gear like this. If you will extend it, that's why these 14.5 degree gears or full depth involved gears, they are known as radial gears. Why known as radial gears? Because that curve is passing through the center of the gear. Now, if you will see here, thickness at the bottom or at the root is less. Is it correct? See that from this point, from this point to this point, if you measure the length between these 2 points, you will find that length is maybe sometimes it is 10 mm or 20 mm, we consider 20 mm. But these line curves are known as radial curves or radial lines. Now, next is 20-degree full depth involute system. Now you can see the difference. In case of 20-degree full depth involute system, module is 1 times module. Sorry, addendum is 1 times module. Dedendum is 1.25 times module. Earlier it was 1.157 times module. Now you are getting the difference. What is the difference between 14.5 degree and 20 degree? हे डायग्राम वर तुमच्या डिफरन्स लक्षात आला पाहिजे. इथे अँगल किती आहे? व्हॉट इज अँगल? 14.5 degree. Here 20 degree. It's like these differences you have to understand by observation method. Now tooth space, it is proportion is same, 1.570 times module. Tooth thickness is proportion is also same, 1.570 times module. Now if you will see this 20-degree full depth involute teeth or tooth, here length is more between at the root as compared to this length. This length is more. That's why you can say that 20-degree full depth involute tooth is stronger than 14.5 degree. Base जर तुमचा छोटा असेल, स्ट्रॉंग असणार आहे का तुम्ही? छोटा म्हणजे ती लेंथ किंवा त्याचा एरिया, बेसचा एरिया. आपण बघतो तुमच्या घरी शेती असेल, समजा ते शेवरीचं झाड असेल किंवा ते शेवग्याच्या शेंगेचं झाड असेल, त्यांचा बेस किती छोटा असतो? बेस म्हणजे the diameter of that trunk म्हणजे खोड. वनस्पती तुम्हाला पार्ट माहिती आहेत ना सगळे? रूट, ट्रंक, ब्रांच, लीव्स, फ्लॉवर्स, fruits. You must know the knowledge of biology also. Don't think that engineering is nothing but only mathematics. Engineering is nothing but biology also, because whatever concepts are there, all the concepts we have taken from biology subject. In case of design subject or in case of your strength of material subject. In strength of material subject, your cantilever beam is there. And if you consider one tree is also one type of cantilever beam. Because one end is, other end is tree. Is it correct or not? Or any one branch of the tree if you will take, that branch is fixed here. Another end of the branch is free, so that you can hang on that branch and take swinging motion. Is it correct or not? Swinging motion म्हणजे तुम्ही झोपाळ्यात खेळाय ना, तो असा हाताने बांधलेला पूर्ण लोंबकळ आहे ना लहानपणी, तो आता पण लोंबकळत असतात. Therefore, that branch of the tree is nothing but cantilever beam. Therefore, this in case of 20 degree and full 20 degree and 14.5 degree, you are getting the difference now. Same is written here. Whatever I am telling, same things are written here. 14.5 degree full depth involute system. The basic rack of this system is composed of straight sides except for the fillet arcs. Fillet arc म्हणजे हा radius. In this system, interference occurs when the number of teeth on the pinion is less than 23. This system is satisfactory when the number of teeth on the gears is large. If the number of teeth is small, and if the gears are made by generating process, undercutting is unavoidable. Undercutting means interference. 20 degree full depth involute system. The basic rack of this system is also composed of straight sides except for the fillet arcs. In this system, interference occurs when the number of teeth on the pinion is less than 17. The 20 degree pressure angle system with the full depth involute teeth is widely used in practice. It is also recommended by the Bureau of Indian Standards. Now, what is happening when pressure angle increases? Pressure angle increase झाला ना आता. पहिला किती होता? 14.5 डिग्री. आता किती झाला? 20 डिग्री. म्हणजे 14.5 डिग्रीची अशी लाईन असेल तर 20 डिग्री असा होणार ना. हा अँगल असणार हा. 14.5 डिग्री 20 डिग्री. हा अँगल इन्क्रीज झाला की काय होतंय? What is going to happen? Increasing pressure angle improves the tooth strength but shortens the duration of contact. Decreasing pressure angle requires more number of teeth on the pinion to avoid undercutting or interference. The 20-degree pressure angle is a good compromise for most of the power transmission as well as precision gearboxes. The 20-degree pressure angle system has the following advantages over the 14.5 degree pressure angle system. First, it reduces the risk of undercutting. Second, it reduces interference. Third, due to the increased pressure angle, the tooth becomes slightly broader at the root. This makes the tooth stronger and increases the load carrying capacity. It has greater length of contact. What is the meaning of this statement? Due to the increased pressure angle, the tooth becomes slightly broader at the base. This is the base partner at the root. This makes the tooth stronger and increases the load carrying capacity. Hey, baga. 14.5 degree, if you measure this much distance at the base, this distance is smaller than this distance. Now this 20 degree full depth involute teeth, or this curve is there. This curve will also pass through the center of the gear. Always remember, this curve will also pass through the center of the gear. The main advantages of 14.5 degree pressure angle system is its quietness of operation. Now next is the (20-degree) stub involute system. Now you just see the difference between stub involute and other gears. Here what is the addendum height? 0.8 times module. Earlier it was one module only. Dedendum is here one module. In earlier cases, addendum is one module, dedendum is 1.25 times module. Here, dedendum is one module, addendum is 0.8 times module. This tooth space and tooth thickness remains same. Therefore, what is the stub involute gears? Stub involute gears means what? Suppose these two gears are there, they are in contact with each other. And suppose interference occurs. Interference means what? The tip of the tooth will go inside the base circle of another gear. Like this it will happen. Therefore, this tip of the tooth, suppose this gear will rotate, this tip of the tooth will cut portion at the bottom of another gear. Is it correct? हे समजा अशी झालं हे असं करणार आहे का? तर त्याला काय होणार? थोडंसं मटेरियल काढणार ना तो टिप ऑफ द टूथ. टिप म्हणजे टोक. टिप म्हणजे काय? लहानपणी पेन्सिलला टोक करायचा ना, मोठेपणी पण करताय. लीड पेन्सिल वापरताय. उलट साधीच पेन्सिल चांगली त्या लीड पेन्सिल पेक्षा पण. लक्षात ठेवा. लीड पेन्सिल पिन का आपण ते हवा करायला जातो आणि ते सारखं तुटतं येतो. त्यापेक्षा साधी पेन्सिल घ्यायची आपली 1 रुपयाची आणि तीच सगळीकडे वापरायची. Therefore, this tip of the tooth will undercut. Or undercutting means removing of the portion at the bottom of the tooth. त्याच्यामुळे काय होणार, इफ पोर्शन विल बी रिमूव्ड ॲट द बॉटम व्हॉट विल हॅपन, सांगा बरं. तो दुसरा गिअर टू वीक होणार का नाही. आता तुम्ही झाड तोडताना कसं तोडता, खाली बुंद्यामध्ये गाव घालता ना, बुंद्यामध्ये गाव घालताना ते मटेरियल थोडं थोडं काढता ना, तसंच ते गिअर टूथचं होतं. मग तो जेव्हा बुंदा थोडं 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 वीक होत जातो, मग तुम्ही काय करता, त्याला हाताने पाड, बरोबर का नाही. असं तुम्ही हाताने झाड पाडल्यानंतर पडणार आहे का, नाही. Therefore same thing is there of gear. Therefore once that portion of the gear tooth is removed at the bottom, what will happen, at one point will reach, that gear tooth will break. Therefore that is nothing but interference or undercutting of gears. Therefore, and that's why what we have to do, we have to remove the top portion of the gear tooth by grinding process. You will see, by grinding process, now addendum height is reduced to किती झाली addendumची height इथं 0.8 मॉड्यूल, पहिल्यांदा किती होती 1 मॉड्यूल होती. मग काय करायचं, इंटरफरन्स हा टॉप पोर्शन काय करायचा, काढून टाकायचा ग्राइंडिंग प्रोसेसने. grinding process you have studied. In grinding process, material is removed in terms of microns. Therefore, this top portion is removed. Therefore, addendum height is decreased. Addendum height decrease झाली म्हणजे काय होणार, परत clearance तयार होणार and gear can rotate. No interference will occur. Therefore, this is known as 20-degree stub involved teeth or stub involved system. Therefore, 20-degree stub involved system, the gears in this system have shorter addendum and shorter dedendum. The interfering portion of the tooth, that is a part of the addendum, is thus removed. Therefore, these teeth have still smaller interference. This also reduces the undercutting. In this system, the minimum number of teeth on the pinion to avoid interference is 14. Since the pinion is small, the drive becomes more compact. Stub teeth are stronger than full depth teeth because of the smaller moment arm of the bending force. Moment arm म्हणजे काय? Moment arm म्हणजे addition of addendum plus dedendum. इथे addition of addendum plus dedendum किती होती? 0.8 अधिक 1 म्हणजे किती 1.8. अगोदर किती होती 2.25. इथे किती 2.157. कारण गियर फोर्स, गियर टूथ, you have to consider it as cantilever beam. Already I have told. Gear tooth you have considered it as cantilever beam because its force is acting along this line. Force आणि हे distance, त्याच्यामुळे काय तयार होतो मोमेंट. मग डिस्टन्स जर वाढलं तर मोमेंट काय होणार, जास्त होणार. इथं मोमेंट जास्त आहे आणि ह्या दोन्ही टीथ पेक्षा याची मोमेंट काय असणार, कमी असणार. बिकॉज दिस distance means addition of addendum plus dedendum, that distance is reduced or decreased. Therefore, this also reduces the undercutting. In this system, the minimum number of teeth on the pinion to avoid interference is 14. Since the pinion is small, the drive becomes more compact. Stub teeth are stronger than full depth teeth because of the smaller moment arm of the bending force. Therefore, the stub system transmits very high load. Stub teeth results in lower production cost as less metal must be cut away. The main drawback of this system is that the contact ratio is reduced due to short addendum. Due to insufficient overlap, vibrations are likely to occur. Therefore, this is the basic theory of the gear. I think you have understood it. This basic theory is not there in your syllabus, but still we have taken so that you must understand what are different types of gears, what is the gear. Actually, in syllabus, actually your point starts from this design considerations. But that theory is very important. If that theory you will understand, definitely this remaining part you can understand. Therefore, next point is design considerations. Now, what are the design considerations of the spur gear? Power to be transmitted, speed of the driving gear, speed of the driven gear or velocity ratio, then center distance. Center distance म्हणजे काय? What is meant by center distance? When the two gears are in contact with each other, the distance between the centers of the two gears. The distance between centers of the two gears is known as center distance. And what is the shape of the gear usually? Circular shape. Therefore, for circle always there is a center. कुठल्याही सर्कलला सेंटर असतोच का नसतो? सेंटर शिवाय तुम्ही सर्कल काढू शकत नाही. Therefore, distance between the centers of the two circles is known as center distance. Now, next point is gear tooth failures. Now, already I have told gear tooth failure म्हणजे काय? What is the failure? Failure म्हणजे in Marathi it's called as नापास होणे. म्हणजे स्टुडंटच्या लाईफ मध्ये नापास हा शब्द आपण सगळीकडे वापरू शकतो ना. असं काय नाही की फक्त अकॅडमिक असतानाच आपण नापास शब्द वापरू शकतो. नापास शब्द हा सगळीकडे वापरतात. नापास, ना म्हणजे नाही, पास नाही, बरोबर आहे का? ऍक्च्युली पास हा इंग्लिश शब्द आहे आणि हा मराठी शब्द आहे. सॉरी, मराठी अक्षर आहे, बरोबर आहे का नाही? पास हा इंग्लिश शब्द आहे आणि ना हा मराठी शब्द आहे. सॉरी, मराठी अक्षर आहे. ना अधिक पास म्हणजे नापास. Therefore, gear tooth failure takes place by two processes: breakage of the tooth and next is surface destruction. Breakage of the tooth, just now I explained. आता मी तुम्हाला सांगितलं ब्रेकेज ऑफ टूथ कशामुळे होतं? इंटरफरन्स और अंडरकटिंग प्रोसेस. ब्रेकेज ऑफ टूथ म्हणजे गिअरचा दात तुटणे. म्हणजे तुम्हाला माहिती आहे आपला पण दात तुटतो. आपल्याला दात आहेत ना? नाहीत. 32 teeth are there. teeth सॉरी. आपले पण लहानपणी असे दात तुटलेले आहेत. मग ते थोडं मोठं झाल्यानंतर परमनंट दात येतात. तसं गिअरचं नसतं. गिअरचा दात तुटला की तुटतो. तो कारण तिथं नवीन उगवून येत नाही. Therefore, because of interference and undercutting, that gear tooth breaks. That is known as breakage of the tooth. That process I have explained. Next is surface destruction. Surface destruction म्हणजे काय? Again, I will go to this figure. See that this is the surface. This is the surface of the gear tooth. Complete हा असा. See that this surface. This is the whole surface of the gear tooth. Therefore, whenever two gears are in contact with each other, line contact is there, but this surface of the gear tooth becomes damaged after some years, maybe due to improper lubrication or this material of the gear or forces acting on the gear or any particle, foreign particle will come between the two surfaces of the gear. and it will trap here. And because of this, what is going to happen? Scratching on the surface takes place. बरोबर आहे का? त्या surface वर काय होणार? Scratches तयार होणार, कधी खड्डे पडणार. बरोबर आहे का नाही? त्यालाच म्हणतात surface destruction. Surface destruction. Now that surface destruction is classified into 5 types. First is abrasive wear, second is corrosive wear, third is initial pitting, fourth is destructive pitting, and fifth is scoring. Now we'll see all these gear failures. Abrasive wear. Abrasive wear म्हणजे काय? Abrasive wear, abrasive म्हणजे काय? Abrasion. One small particle will come between the two teeth, and when that gear will rotate, that particle will also rotate with that gear teeth. Is it correct or not? Sometimes that particle will move along the surface of the gear. तो particle surface of the gear move झाला सारखा तर काय होणार? त्या गिअरच्या सरफेस वरती स्क्रॅचेस तयार होणार, म्हणजे लाईन तयार होणार. बरोबर आहे का? Therefore, these small lines you are observing here, this is known as abrasive wear. Abrasive wear. The tooth surface is scratched by foreign particles in the lubricant, such as dirt, rust, and weld spatter of metallic debris. This can be reduced by filtering oil, using high viscosity lubricants, and surface hardness, or increasing the surface hardness of the gears. Next is corrosive wear. Corrosive wear म्हणजे काय? Corrosion म्हणजेच काय? गंजणे. आपण तुम्हाला माहिती आहे घरी किंवा आपल्या मोटरसायकलला, 2 व्हीलर 4 व्हीलर किंवा सायकल आपण कन्सिडर करू, लहानपणापासून जी आपण गोष्ट चालवतो, आपण काय करायचं? त्याला सायकलला ऑइलिंग करायचो का? नाही. घरात पण आपण कुठे कुठे हिंजेस असतात on the in whatever the door is connected to the frame with the hinge. Hinge means Marathi is called as bijagun. त्याचा जसा आवाज येतो बघ कधी कधी, कार 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 नाही. आपण तिथे काय करतो? खोबरेल तेल सोडतो. खोबरेल तेल म्हणजे तुमच्या डोक्याला लावायचं ते. आपल्या डोक्याला आपण कुठलं तेल लावतो? पॅराशूट तेल लावत नाही. पॅराशूट ही कंपनी. खोबरेल तेल लावतो का पाम तेल लावतो? समजलं का तुम्हाला? तुम्ही म्हणता मी पॅराशूट लावतो. पॅराशूट तेल लावत नाही, तुम्ही खोबरेल तेल लावतो. Therefore, we are doing the lubrication. We are doing the lubrication. See that this is corrosive wear. Corrosion होतं ना? Corrosion मुळे काय होतं? थोडे थोडे लेअर निघून जात नाही का सरफेस वरची? तिथे तुम्ही हाताने किंवा पॉलिश पेपरने जर घासला तो गिअर किंवा कुठला तर पार्ट, थोडे थोडे पार्टिकल निघत नाहीत का त्याच्यात? पार्टिकल निघतात म्हणजे काही विअरच होतं ना. Therefore, that's why it is known as corrosive wear. Therefore, corrosive wear, the corrosion of the tooth surface is caused by corrosive elements such as extreme pressure additives, present in the lubricating oils and foreign materials due to external contamination. These elements attack the tooth surface, resulting in fine wear uniformly distributed over the entire surface. The corrosive wear can be controlled by complete enclosure of the gears, selecting proper additives, and replacing the lubricant at regular intervals. आपण काय करतो, lubricant regular interval replace करतो. तुम्ही जर बघत असाल, for the if you are observing that, suppose we are doing servicing of our two-wheeler and four-wheeler, is it correct? Servicing करतो का आपण two-wheeler four-wheeler ची? नाही करत. तर त्यावेळेस काय करतो आपण, तर तो मेकॅनिक काय करतो, ऑइल काढतो ना गिअर बॉक्स मधलं. काय काढतो, विस्कॉसिटी कमी झालेली असते, ऑइल पातळ होतं, म्हणजे विस्कॉसिटी कमी झाली. ते तुम्ही बघितलं तर ते ऑइल काळ पडलेलं असतं. पहिल्यांदा जेव्हा नवं ऑइल असतं तेव्हा त्याचा रंग कसा असतो, लाल असतो, लाल किंवा थोडा येलोइश असतो. आणि 3-4 महिने तुम्ही गाडी वापरून जेव्हा ऑइल बदलता तेव्हा ते ऑइल काळ झालेलं असतं. मग ते मेकॅनिक आपल्याला म्हणतो की सर्व्हिसिंग, सर तुम्ही आता सर्व्हिसिंग अजून 3-4 महिन्यांनी या बरं का. तेव्हा तू सांगतो आपल्याला दर 3 महिन्यांनी गाडीची सर्व्हिसिंग काय करायची, किंवा दर 4 महिन्यांनी. Why? Because he is replacing that lubricant in the gearbox. If he will not replace that gearbox lubricant, what will happen? The gear काही दिवसांनी corrosion होतील आणि ते ऑइल खराब झालेलं असतं ना. Sometimes there are chances that the gear will break also. कधी कधी तुम्हाला माहिती गाडी चालवता चुकून जर गिअर चुकीचा पडला गाडी बंद पडते. गाडी बंद पडताना का आवाज कसा येतो का गिअर बॉक्स मधनं, खाड 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 का नाही येत, येतो का नाही. मग तो ते जुनं जो लुब्रिकंट असेल त्यावेळेस कसा आवाज झाला तर काय होईल, ते गिअर टूथ एकमेकावरती आपटतात ना असे, त्याच्यामुळे तो मोठा आवाज येतो. समजा गिअर टूथ ची स्ट्रेंथ कमी असेल तर काय होणार, गिअर टूथ मोडणार, ब्रेक होणार. Therefore, this is the corrosive wear. I think we should stop here. This is correct. This next type of wears we will see in next lecture.